All right, so Chapter 5, Lesson 1 is Algebraic Expressions. Now, a variable, make sure you write these definitions down. A variable is a symbol that represents an unknown quantity. An algebraic expression, such as n plus 2, is an expression that contains variables, numbers, and at least one operation. So, we've talked about variables representing unknown quantities before, right? And also, we've talked about algebraic expressions. Now you have a definition for it. So the n plus 2, that is an algebraic expression. Another example of an algebraic expression would be like 5x. 3x plus 2 over y. Those are algebraic expressions, okay? So here, the expression, the quantity of f minus 32 times 5/9 can be used to convert a temperature from Fahrenheit to Celsius. In this algebraic expression, the variable up here represents the temperature in degrees Fahrenheit. Which variable is that? That would be F. So F represents the temperature in degrees Fahrenheit. So normally when you have a formula like this that is specific to something, they will use variables that are meaningful. Okay, so F is for Fahrenheit. If Celsius was in there, C would be Celsius. Is everybody clear with that? Okay. What do I not like about this, how they wrote this? They used the multiplication. They used x for the multiplication here, right? We're working with variables. So if you're writing this formula in your paper, on your paper, if you wrote the x for the multiplication, wouldn't it look like a variable? Yeah. So we want to make sure that when we're using variables, you're going to use the dot or you're going to use parentheses. So the first thing we're going to do here is we're going to evaluate an algebraic expression. Okay? The branch of mathematics that involves expressions with variables is called algebra. In algebra, the multiplication sign is often omitted. So here we have 6d, 9st, mn, and a to the third power, or a cubed. Here, 6d, that means 6 times d, right? 9st means 9 times s times t. mn means m times n. All right. And then over here, a to the third power, or a cubed, means a times a times a. Now, it says the numerical factor of a multiplication expression that contains a variable is called a coefficient. So up here, 6, in the 6d, 6 is the coefficient. The coefficient is a number that is in front of the variable. So for 9st, 9 is the coefficient. If you had 5x, 5 in front of the variable would be the coefficient. Is everybody clear with that? Okay. Expressions like y over 2, remember that fraction bar is division, right? So that can be written as y divided by 2, or we could say y times 1/2. Okay? And don't forget, we're not going to use the x for multiplication anymore. Okay? All right. So here we have y divided by 2. Now remember that dividing by 2 is the same thing as multiplying times 1/2. That's the reason why y over 2 can be written as y times 1/2. You got it? All right. So here are some examples. Now, example 1, 2, and 3, we are evaluating. And when we evaluate, you guys, I want you to make sure you know this definition. Evaluate means to substitute and simplify. Please write that down. So evaluate means to substitute and simplify. Okay, so you've written that down. So here, example 1 says evaluate 2 times a quantity n plus 3 if n equals -4. Now we've done problems like this before, right? So here we're just going to take that -4 and then we're going to put it in for n. So here we're going to substitute n for -4 in for n. So we have 2 times the quantity, negative 4, plus 3. And then, using our order of operations, we're going to simplify. So, negative 4 plus 3 is equal to negative 1. And now we have 2 times negative 1, which gives us negative 2. If you are showing your work correctly, you're going to see your inverted triangle. Okay? Example 2 is just showing with 2 variables, substituting 5 for W and 3 for V. So we substitute in 5 for W, 3 for V, and then we simplify using our order of operations. So we're going to multiply first. So we have 8 times 5 is 40, minus 2 times 3 is 6, and we end up with 34. And then finally, with example 3, we're going to simplify 4y cubed plus 2 if y is equal to 3. Now remember, the y cubed means y times y times y, right? So we're going to substitute 3 in for y, so that's going to be 3 times 3 times 3. So 3 times 3 times 3 is 27. So now we have 4 times 27 plus 2. Order of operations says we're going to multiply first. So we have 108 plus 2, that gives us 110. And then once again, if you're showing your work correctly, you will see your inverted triangle. All right, so for example A, we have C minus 3, where C is equal to 8. So wherever there's a C, we're going to substitute 8. So we're going to substitute 8 in for C, and then we're going to simplify. 8 minus 3 is 5. And once again, there is your inverted triangle. How about letter B? That's going to be 15 minus 8. Very good. And 15 minus 8 is 7. Piece of cake, right? Now here we have 3 times the quantity, C plus D. So what are we going to put in for C? 8. And how about D? Negative 5. Say it correctly. So we have 3 times the quantity, 8 plus, and then here when you put in your negative 5, don't forget you want that to be in parentheses, right? And then so we're going to have a double parentheses in there. And now we can simplify using our order of operations, doing the parentheses first, doing our grouping symbols first. So that's going to be 3 times 8 plus negative 5 is positive 3. Because remember, take the sign of the higher number, right? So that's going to be 3 times 3, which is equal to, perfect. You got it? So here, what's my next line going to say for 2C minus 4D? 2 times 8.
4 times negative 5.
Right, very good. Minus 4 times negative 5. And now we can use our order of operations. So we're going to do our multiplication first. So 2 times 8 is 16 minus, now 4 times negative 5 is negative 20. And we're going to put that in our parentheses. So now we have 16 minus a negative 20. It's subtraction. So we're going to do leave it, change it, change it. So we have 16 plus positive 20 now, and that's going to be 36. Very good, 36. All right, so what am I going to substitute in for D minus C squared? Negative 5 minus 8 squared. Very good. So now we simplify using our order of operations. So what comes first? The exponents. So we have negative 5 minus 8 squared, which is 64. And now, because it's subtraction, we're going to do leave it, change it, change it. So negative 5 plus negative 64 is negative 69. Got it? Awesome. All right, how about example F? What am I going to substitute in there? 2 times -5 squared. Very good. Make sure you put your parentheses, and the squared goes on the outside. Okay? The squared goes on the outside. Plus 5 times d, which is, again, -5. Okay? And now we simplify. So we're going to do the exponents first. So the exponent, -5 squared. -5 squared means -5 times -5, which is negative times a negative is a positive. So this is going to be 2 times +25. Remember, nerds and nerds? All right. Plus 5 times -5 is -25. Very good. And now we're going to do our multiplication. So 2 times 25 is 50. That's like normal. Plus the -25. Does everybody see how I keep rewriting the each line? Okay. And then we're adding different signs. So what's the rule? Right. And what do I do to the digits? Subtract. You subtract and take the sign of the higher number, right? So this is going to be 50 minus 25, which is 25. The 50 is larger, so it's positive, so my answer is going to be positive 25. You guys, you noticed when I was saying it's very important, don't forget your parentheses, right? Now here, if I'm looking at, let me use red. If I'm looking at this right here, I said the exponent goes on the outside of the parentheses. Now, I want to show you what will happen if you put that exponent on the inside of the parentheses. So on the inside of the parentheses, that would be -5 squared, right? Up here, inside the parentheses, it's -5 times -5, because the 2 is connected to is right next to the parentheses, which includes everything inside the parentheses. Down here, the 2 is right next to the what? The 5. It's right next to the 5, which does not include the negative. So this is going to be 5 squared, which is positive 25, and then the negative gets applied afterwards. Does everybody see that? You see the difference between what's written up here is going to give us a positive 25, and what's written down here is going to give us a negative 25. Example 4 says an athletic trainers use the formula 3 times quantity 220 minus A over 5, where A is a person's age, to find the minimum training heart rate. Find Latrina's minimum training heart rate if she is 15 years old. So here, the thing that we're looking at is the fractions, the fraction bar. Remember we said the fraction bar is also a grouping symbol. So that means that when I simplify this expression, we have to simplify the numerator first. And if I have to simplify the denominator, then I'll simplify the denominator. Okay, that's how the fraction bar groups the numerator and the denominator. And once those are simplified, then you can divide. So in this example, we're going to simplify the numerator first. So we're going to do 220 minus 15. That gives us 205. Multiply times 3, 615. And now you can divide. Does everybody see that? Okay. So let's do this one together. So it says to find the area of a triangle, we're going to use B times H divided by 2, where B is the base and H is the height. Don't forget that dividing by 2 is also the same thing as multiplying times 1/2. So that's the reason why we could write 1/2 times the base times the height, right? But since we used BH divided by 2 in this, it's written for us in the problem, then that's the one we're going to use. says, what is the area in square inches of a triangle with a height of 6 inches and a base of 8 inches? So we're going to write our formula, BH divided by 2. And then we're going to substitute. So what goes in? What goes in for the B?
8.
8. And what goes in for H? 6. And we're going to divide by 2. So 6 times 8 is?
48.
48. Does everybody see that I'm working horizontally here? And then we're going to divide by 2. And then 48 divided by 2 is? 24. 24. And then what are my units going to be? Inches squared, because we're looking at area. Very good. All right, so now we're going to write an expression. So to translate a verbal phrase into an algebraic expression, the first step is to define a variable. Now, when you define a variable, what you're doing is you're going to choose a variable to represent the unknown quantity. Okay? So here it says, make sure you write down that definition there. Here it says, Marissa wants to buy a DVD player that costs $150. She already saved $25 and plans to save an additional $10 each week. Write an expression that represents the total amount of money Marissa has saved after any number of weeks. So, in the problem, we see here that she is going to save 25. She's saving $25 plus $10 each week, right? She's saving $25 and plans to save an additional $10 each week. So that's what we're going to write into our expression. Now, what is it that we don't know? We don't know the number of weeks. Very good. We don't know the number of weeks, so that is what we're going to use to define our variable. So we'll say W is equal to the number of weeks. Okay? So now, once we know what the variable is, we know what we're trying to write in the expression, now we can translate that English to math. So here, she's saving $25 plus the $10 each week. And of course, each in math means multiply. So there is the expression that we're writing. So example 6 is using the expression that we have in example 5. It says, will Marissa have enough money to buy the $150 DVD player in 11 weeks? So here, now we're going to evaluate when W is equal to 11. So now we're going to substitute 11 in for the number of weeks, and then we're going to simplify. So 25 plus 10 times 11, that's going to give us 135. So will she have enough money? No, she will not have enough money. She needs to save some more, right? So an MP3 player costs $70 and song downloads cost 85 cents each. Write an expression that represents the cost of the MP3 player and the number of downloaded songs. Then find the total cost if 20 songs are downloaded. So the expression from the problem, it says that the MP3 player costs $70 and song downloads cost 85 cents each. Now, the expression that they want us to write is the cost of the MP3 player and the number of downloaded songs, right? So we have the cost of the MP3 player and 85 cents for each song. Now, we want to define our variable. What is it that we don't know here? So, we don't know how many songs there are. So we're going to define, so let's say D for downloads is going to be the number of songs. Okay? So there we defined our variable, and now we can write our expression. So the cost of the MP3 player is $70. And so we're going to add to that 85 cents for each song. So this is going to be 0.85 for each song. That's times D for the downloaded songs. Is everybody with me? So now the final thing says, then find the total cost if 20 songs are downloaded. So now we have our expression. We're going to substitute and simplify. So what goes in for D? Very good. So we have 70 plus 0.85 times 20. So 70, when we simplify, plus 85 cents times 20 gives me 17. So how much is it total is going to be costing? $87. Is everybody clear?